All right. So what we're going to do is continue on with domain one, threat detection and incident response. For that, remember to like, subscribe, and share if you'd like to. Okay, so question 14. A large company that uses AWS recently received an email from the abuse team. The email informed them that an IAM user with the company's AWS account has their access key and secret access key pair published in public code repos. Although there are no signs yet of any compromise within the company's AWS account, the IAM user in question is designated as a service account and is used in a critical customer-facing production application with hard-coded credentials. To address this situation and minimize the application downtime, you've been tasked as a certified security specialist for implementing a solution that protects the account from unauthorized access. What steps would you suggest? So, A is the answer. And inactivate the publicly exposed IAM access key. Okay. Why is this? Well, it's really all of them. So you'd inactivate the publicly exposed access key, create a new access key, and secret access key pair for the IAM user, update the application, use the new credentials, revoke any temporary STS, security token service credentials associated with the IAM user, and delete AWS management console credentials associated with the IAM user. Why? So this prioritizes securing the AWS account first by inactivating the publicly exposed IAM access key, which prevents unauthorized access, then creates new credentials and updates the application to minimize downtime. Finally, revoking the STS credentials and deleting the console credentials further reduces risk. Let's see if we can go in here, find this. So this is some supporting information. All right. What do you do in case of this? And this is much more winded, but this is determining US credential access, invalidating the credentials, invalidating STS, all right, restore the appropriate access. But this goes all through what we've just discovered. Invalidating the temporary credentials. And here you'll have it in summary, right? It's an unlikely event, but this is the full steps that you would go through to accomplish this, all right? So any options that would be incorrect would be any that would delay inactivating the publicly exposed key, because this should be done as the first step. And anything that starts with revoking STS credentials would cause immediate application downtime. So there's an order that this has to be done, but all of these would be necessary. Next question. All right. For a threat alert raised by the security team, a company needs content inspection of traffic passed through a Route 53 resolver outbound endpoint. As a security specialist, how would you implement the solution? So this answer is going to be A, to view traffic passing through Route 53 resolver endpoints, configure a VPC for traffic mirroring. Okay. So traffic mirroring copies network traffic from elastic network interfaces, ENIs, and sends it to security appliances for content inspection, threat monitoring, and troubleshooting. All right. It supports filters and packet truncation for extracting specific traffic. So why are the other ones not correct? Well, let's get some supporting documentation. So this one would be the best answer, right? Okay, so configure for the EC2, configure the EC2. So this is one for network connectivity. And so for the VPC portion, shows this, use the target instance of the ENI to create a traffic mirror target, create the filter for the DNS traffic, and the VPC associated with the Route 53 rule set to this domain DNS queries will be able to accomplish this. All right, and from here, you have more information about how you view the mirror traffic, depending on your EC2, and this would solve the problem. Why are the other ones incorrect? And this is more sort of documentation about how traffic mirroring works, so you should look this up on your own time to further cement this in your head. All right, so VPC flow logs. All right, so VPC flow logs only capture metadata about traffic, not actual traffic content needed. Okay, Route 53 querying. So this would only capture DNS query information. So like the domain, the date, the time, the record type, response code. It's not really relevant to content inspection. All right, and then CloudTrail. So this would only capture API calls and events, not traffic content. Okay, next question. A hybrid AWS network is configured to route internet traffic such that it egresses from an on-prem gateway rather than from the VPC internet gateway. Since enabling GuardDuty, an error has been repeatedly seen in the GuardDuty findings. Unauthorized access, IAM user, instance credential exfiltration outside AWS. How would you address this issue so the VPC's internet traffic that egresses from an on-prem gateway does not trigger the given error? So it's going to be two. This would be use suppression rules that create a rule that consists of two filter criteria. The criterion is finding type, which would be the unauthorized access, IAM user, instance credential, exfiltration outside AWS. And then the second filter criterion is API caller IPv4 address with the IP address or side range of the on-prem internet gateway. Okay, so why is this correct? Okay. So suppression rules automatically archive findings that match specified criteria. So this is a specific finding type that indicates legitimate use of the instance credentials from the known on-prem IP, gateway IP. So suppressing based on the correct finding type and API caller IP address would prevent false positives. Okay, let's get some supporting documentation out here. Okay, so we'll see some suppression rules. When you create a suppression rules that archives findings, threat detection won't use these for attack sequences. Okay, so there's common types you can use. So unauthorized access type, infiltration. This looks like this would be it. Outside API, right? So this would be it, right? So this uses suppression rule to automatically archive findings generated when a VPC networking is configured to route internet traffic for egress to from an on-prem rather than from a VPC. Okay. And this would also support this. It's generated when the network is configured to route internet traffic such that it egresses from on-prem rather than from a VPC internet gateway. So common configurations like AWS Outposts, VPC VPN connections can result in traffic routed this way. If it's expected, it's recommended that you use suppression rules and create a rule that consists of two filter criteria. The first filter criteria should be what we discuss here with the instance credential exfiltration outside AWS. And the second one is the API caller IPv4 address. Okay. So with the IP address or side range of the on-prem internet gateway, the example below represents the filter you use. Okay, so you see this here would show this. All right. All right, so why are the other ones incorrect? Let's see. Okay, so the SSH brute force. All right. So the brute force finding type, this is not relevant to the credential exfiltration issue described. Okay. And then trusted IP list. Okay. So this prevents non-DNS findings from trusted IPs, but doesn't address this specific use case of suppressing legitimate credential usage. All right. So that is going with the egress from the on-prem. Okay. All right. 31. Next question. All right. During regular maintenance tasks, an application support team noticed an abnormal activity on an EC2 that's configured with an EBS volume. The team immediately informed the security engineer of the anomaly. The instance is part of an auto-scaling group fronted by an elastic load balancer. What immediate steps should the security engineer take for preventing any further attacks to secure the connecting systems and understand the root cause? So it's going to be A. What is this? Remove the instance from the auto-scaling group and deregister the instance from the elastic load balancer. Place the instance within an isolation security group and snapshot the EBS data volumes that are attached to the EC2. Launch an EC2 instance with a forensic toolkit and attach an EBS volume created from the snapshot of the suspicious EBS volume. That sounds fantastic. All right, so why is this correct? Okay, so this is AWS recommended security response, right? You isolate the incident, you isolate the instance, you preserve evidence through the snapshot, conduct a forensic analysis on copies rather than the live systems, and this maintains evidence integrity while allowing investigation. Let's get some information over here. Okay. All right. So we'll go on. So this is going to be buried in here. I can't. Snapshot. Let's see if we can find this. Oof. I have to do. Yes, this is APIs. Oof. Sharing snapshots. This is going to be buried in here. cross-account permissions. This is going to be in here. Okay, launching forensic workstations. Oh, that's closer. Okay, some of your instance response. So this is probably it, the closest one here. From the stopped instances, this is about investigating it, but it's not specifically covering it. But let's go into why the other ones are incorrect, because we'd be in here all day. Okay, so let's see. So direct connection to the EC2. All right, so where is this? Okay. Let me see. What is this saying? Deregister the instance, remove it from the auto scaling, deregister it, launch a new one, allow the forensic tool to connect to the suspicious instance. No, that's not going to be good. So direct connection. So this violates the isolation principle, and security groups would block connections anyway. All right. That's why you wouldn't do that one. Okay. So detaching the EBS volume directly. Okay. So this doesn't preserve the original evidence and connects potentially malicious storage directly to forensic systems. Okay. And then ENI traffic. So this violates isolation principles and doesn't provide proper forensic investigation capabilities. So you really want to have it a copy of the storage to be investigated with the forensic EC2. That's really going to be it. So that snapshots can be critical, isolation is going to be critical, and then you could be able to go from there. All right. So next question. All right. So companies created trails in CloudTrail for all its AWS accounts as a security best practice. Recently, the company's security team has highlighted increased user login failures for a particular AWS account and has asked for an immediate fix. Okay. The solution should send notifications to the concerned manager if a user login fails for 3 consecutive attempts within a span of a few minutes, of 5 minutes. How do you implement a solution for this requirement? So there's 2 answers here. All right. So first one, configure CloudTrail to send trail events to CloudWatch logs, create a metric filter for the relevant log group with a filter pattern having event name as console login and error message as failed authentication. And then create a CloudWatch alarm with the threshold parameter set to 3 and the period parameter set to 5 minutes. And the alarm action is a notification sent to SNS topics subscribed to by the concerned managers. All right, so why is this correct? So CloudTrail logs console login or sign-in events, okay? And then metric filters can track failed authentication attempts. And then CloudWatch alarms can then send or trigger SNS notifications when thresholds are exceeded. It's a simple 1, 2, 3 punch. All right, so why are the other ones incorrect? So Athena. All right, so let's see. So while this is functional, this Athena, this is not a good notification. Excuse me. This is not a good notification method, right? So this is unnecessarily complex compared to the native CloudWatch CloudTrail solution with the SNS tied to it. All right, and then CloudWatch or CloudTrail to send trail events to CloudWatch alarm. So you send CloudWatch logs, not directly to alarms. It also uses the wrong event name. So you would need console login, or excuse me, console sign in and console login. All right. So you need all these tied together in the correct sequence. All right. Next question. All right. Company has 2 VPCs, VPC1 and VPC2, configured in 2 different AWS regions that are part of the same AWS account. There's an active VPC peering connection between the VPCs that has been configured in the route tables for both the VPCs. Database is present in VPC1, and the access to the database instance is controlled through a security group defined in VPC1. VPC2 consists of an auto-scaling group that scales in and out any EC2 instances based on CPU usage. Each instance and launched as part of the auto-scaling group belongs to a security group defined specifically for the auto-scaling group. The launched instances need seamless access to the database instance present in VPC1. Which additional step is needed for the solution to work if the route tables are already configured for VPC peering? This is thing A. Add an inbound rule to the security group of the database instance in VPC1 with the source as the CIDR block of VPC2. So VPC for the instances launched by the auto-scaling group. I know that this is why. It's because reciprocal, right? So why is this correct, right? So for cross-region VPC peering, you cannot reference security groups from peer VPCs in different regions, so you must use CIDR blocks instead, all right? So the interesting thing, okay, security group ID, okay, so this is incorrect. You can't reference a security group IDs across different regions, okay? For the outbound rules, okay, so this would be both of these outbound rules, right? Security groups have default outbound rules allowing all traffic, right? Or they can do stateful traffic. So these are unnecessary distractors. Okay, so let's see if this has some more. Let's see, CIDR. Okay, it says it right here, you can't reference a security group of a peer VPC. Instead, use the CIDR block. That just answered it. All right. So security groups for each instance must reference. So this is a standard configuration. Private IP, the CIDR range of the instance. If you reference the security group at the other source, this is not allowed traffic. Boom. So you have to reference that CIDR block. All right. Okay. So next question. All right. So as a security specialist, you've received an alert from a log analyzer about the suspicious increase in traffic to your application's login page, probably indicating a potential brute force or credential stuffing attack against the application. The application under attack is configured behind a WAF, web application firewall, using CloudFront and S3. What should be the initial response to this probable attack? There's going to be A, right? Create a URI-specific rate-based WAF rule to prevent a single source IP address from connecting to the login page more than a defined threshold number of times over a given period. Okay, so why is this correct? Okay, so URI-specific rules target the exact attack vector, the login page, okay, with lower thresholds like 100 requests per 5 minutes. So while allowing normal traffic to other parts of the application, this provides precise protection against a specific threat. Okay, and let's get some. Okay, let's see. URI. Okay, so URIs, this will be here. For others, it would be unusual to see a high request count. Specifics, for example, multiple requests in a 5-minute period to an application's login page is suspicious. Right, so URI specific rule can help prevent a single source IP address from connecting to the login page as few as 10 times per 5-minute period, while still allowing a much higher request volume to the rest of the application. That covers it. Right? It's this right here. Right here. Okay. I'm going to store that. All right. So why the other one's incorrect? Okay. So the blanket base rule. All right. So this is a less specific and typically has a higher threshold, typically about 2,000 requests, and may not effectively stop login page attacks. All right. The IP reputation rule. Okay. So this should be a proactive security measure, not a reactive response to active attacks. Okay. And then the TC packet rule. So this is a fictional option. This is not a real WAF rule type. And we'll go to the next question. Okay. As a security engineer, you have been tasked with the job of automating the detection and remediation of threats against your AWS environment using GuardDuty findings. What steps will you follow to implement this solution most effectively? This is going to be A and B. Okay. Configure CloudWatch event to filter GuardDuty findings when a malicious activity is suspected, and then configure the CloudWatch event to invoke a Lambda function to parse the GuardDuty finding and store it in the Amazon DynamoDB table if required. After checking the existing entries in the DynamoDB table, Lambda function then will create a rule inside WAF and in a VPC NAC, and a notification email is sent via SNS. So why is this correct? This creates an efficient automated system response. CloudWatch events filter and triggers the Lambda functions, and then DynamoDB stores the state to prevent duplicate blocking rules. And then the system will automatically update the WAF and the NAC rules and send notifications. This is 1, 2, 3. Perfect. Okay, so what is the supporting information? Okay, so CloudWatch. All right, so you can configure CloudWatch to invoke a Lambda action in response to suspicious or unexpected behavior, and then configure automation flows that both detective and responsive controls might feed into preventative controls to help mitigate threats in the future. And this goes into CloudWatch events, delivers near time to help your resources. And you can see, boom, you can see this right here. Okay, so this will show that GuardDuty finding is raised. CloudWatch event filters to the GuardDuty finding page. Then a Lambda function is invoked by CloudWatch events. State data for block hosts is stored in DynamoDB. Lambda function checks the state table for the existing host entry. Lambda function creates a rule in the WAF and the NACL. The notification is sent via SNS. This is it. And you have a nice illustration. Save that. Let's see, does this have anything? So this would be somewhat related, but not directly to the question. The previous site, the previous URL had that information perfectly. Why are the other two incorrect? So let's see, S3 export. Okay. So S3 exports would add an unnecessary complexity compared to a direct CloudWatch events integration. And then, okay, so GuardDuty, Lambda. So GuardDuty can't directly invoke a Lambda function. It uses CloudWatch events. And then without the DynamoDB, duplicate blocking rules would be created. So you need that DynamoDB for that database in there. Okay, let's go forward. Next question. A security engineer received a GuardDuty security alert pertaining to one of the EC2 instances that is attempting to communicate with the IP of a remote host known to hold credentials and stolen data captured by malware. The security engineer immediately tried to isolate the instance by activating the isolation security group on the instance. However, within a few minutes, the security engineer received a similar alert again. Which of the following represents the underlying reason for this behavior, and what is the solution to remediate the issue? Okay, when you change a security group rule, its tracked connections are not immediately interrupted. The tracked connections need to be configured to change to untracked connections and then apply the isolation security group to isolate the compromised instance. Okay, so why is this correct? So security groups use connection tracking. Existing connections remain active even after rule changes. To immediately terminate connections, you must convert tracked connections to untracked connections by temporarily allowing all traffic that's 0.0.0/0, and then removing all rules to sever the connections. Let's get some. Let's see. Let's see if we can find this. Okay. You can change the rule. Its track connections are not immediately interrupted. The security group sends packets until existing connections time out. To ensure it, okay, interrupted or subject to fire rules regarding the state, you can use NACL for your subnet to do that. And all rules are tracked and automatically tracked. So this error, connections through following not automatically tracked. And then there's more about timeouts. Let's see if we have sever. No. Now this will be the most relevant section. Let's see. An untracked flow of information is immediately interrupted if that flow enables the flow, that rule enables the flow or is removed or modified. So that would do it too. So this would act upon it as well. Okay, so this gives you some more information about this. So why are the other ones incorrect? Okay, let's see. So internet gateway isolation. So internet gateways operate at the VPC level, not the instance level. So this is a distractor. Okay, and then deny rules. So let's see. Yeah, denying the rules. Okay, so security groups only allow traffic. They cannot create deny rules. That makes a lot more sense. And then isolation groups and shutting down the instance. So this is a last resort. This would be a last resort that would destroy the forensic evidence needed for any investigation, right? And you need that for your security engineer security alert. So that would be a last resort. So this would be the primary answer and the correct answer. All right, next question. Okay. As a security engineer, you receive a notification from AWS about suspicious activity in your account. What are the security checks or actions that you'll need to perform before responding to AWS Support Center? So this is A, B, and C. So create new access keys and modify the application to use new ones. Deactivate the exposed account keys, access keys immediately. Subsequently, delete the exposed keys only when you have verified the proper functioning of the application. Then in the IAM console under permissions tab, look for a policy named exposed credential policy, do not remove. If the user has this policy attached, then rotate the access keys for the user. And then if you must retain an EC2 instance for regulatory, compliance, or legal reasons, then create a snapshot before terminating the instance. Those are sound. Those are very sound. Okay, so why would you do this? Okay, so why these are correct? So these follow the security incident responses, right? Secure the credential rotation, identify the AWS flag compromised credentials, and then preserve evidence for compliance. Those are the big three, okay? And then let's get some supporting documentation for this. All right, this is good. All right, so this is going IAM users groups and roles. This is saying remediate this. Okay, so this will be it. Okay, so rotate and delete this. Oops. Check the regular activity notification sent by AWS, create a new access key, modify your application to use the key, deactivate the original key, verify there's no issues with the application. If your application is functional, then delete the original access key, and then delete the AWS account root user access keys that you no longer need or didn't create. It's this right here. Right here. Okay? So you save that, you should be able to understand this question. Okay, so why are the other questions or answers incorrect? Okay, so revoking temporary IAM credentials. Okay, so temporary credentials with long sessions like 12 hours should be revoked if compromised. But that's not exactly what you're doing in this scenario. This is a simple solution for another question. And then to contain, let's see, access key for the IAM. So 5 access keys. This is weird. So okay, so this is incorrect because IAM principals can only have up to 2 access keys, not 5. All right, so this is a misleading answer that seems like a solution, but it's not. Okay, let's go to the next question. Security engineer noticed that an application layer, so layer 7 DDoS attack is underway on one of the critical systems. What should the immediate response of the engineer be to control the damage? So this is saying AMP, create your own WAF rules in your web ACL to mitigate the attack. And then you can contact AWS support to get help with mitigations if you're a Shield Advanced customer. So why is this correct? So for layer 7 DDoS attacks, AWS doesn't automatically apply mitigations to avoid blocking legitimate traffic. Manual WAF rules provide immediate self-service mitigation, and then Shield Advanced customers get access to DDoS response team support. Okay, let's get some. Let's see, operating techniques. This is not. It's useful to know that DDoS. This is very general. I stored a lot of these ones. Okay, so layer 4, layer 3. That's not right. Shield Advanced detects a large amount of this. So for layer 7, here's this. Okay, you can. Oops, what did I just press? Okay, so you can investigate the mitigating attack on your own. And now we have some more. And then if you're Shield Advanced, you can contact the AWS Support Center. Okay, so we're going to have this. And then very likely this. Yeah, here's the specific. Create a rule statement with your WACL or your web ACL that matches your usual behavior. That's going to be it. And then the other piece would be contacting AWS support if you're Shield Advanced. And then, oh, we already went over this. Okay. And then why are the other ones not correct? So SSM documentation, I mean, that's config. So this is a distractor. This has no real application with DDoS mitigation. And then CloudWatch monitoring and GuardDuty. Okay, so these are proactive measures, but not immediate responses tools or immediate response tools for active attacks. All right. Okay, and the next question. A systems admin is no longer able to access the Windows Amazon EC2 instance because the Windows admin password is lost. As a security engineer, you have been tasked with the job of resetting the password of the instance, which is the following steps which you suggest to reset the password using EC2 launch v2. So select 3. It's going to be ABC. Let's go over these. So verify that EC2 launch v2 service is running. Detach the EBS root volume from the instance. Launch a temporary instance and then attach the volume to it as a secondary volume. Delete the .run once file from the instance located at program data /Amazon /EC2 launch /state.run once. Then reattach the volume to the original instance as the root volume and connect to the instance using its key pair to retrieve the admin password and connect to the instance using its current public DNS name. Okay, so why is this correct? Okay, so these are specific steps for EC2 launch v2 password reset. Okay, you detach the volume, you modify on the temporary instance, then delete the run once file to trigger a password reset, then reattach and retrieve the new password. So let's get some supporting documentation for this. You can see it. All right, this is good. This is good. All right, so verify the EC2 launch is running. Boom. Detach the volume from the instance. Boom. And this has full instructions for it. This is full instruction. Attach it to the temporary instance. Boom. And okay, delete the run once file. Boom. In the location. Boom. And then restart the original instance. Boom. And then you should see retrieve the new Windows administrator password using the private key for the new key pair and connect to the instance. This covers the whole gamut. So why the other answers are other answers incorrect? Okay. Why are these incorrect? So EC2 rescue. Okay. These are for EC2 launch version 1, not EC2 launch version 2. That's it. That's for that one's correct. And then the same Windows version, okay, which is BE. So this is incorrect. You need a different Windows version to avoid disk signature collisions. Okay, so this is it's a security issue. Well, operations issue actually. Okay, so next question. All right. Okay, as a security engineer for an IT company, you've received a notice from AWS that the resources for your company's AWS account were reported for abusive activity. What should be your course of action after receiving the notice? This is A, review the abuse notice and reply explaining how you will prevent abusive activity from occurring in the future. You're basically violating AWS's trust. So why is this correct? Okay, so AWS has trust and safety requirements, and these require a direct response from you within 24 hours, explaining what your remediation steps are, right? If you don't answer these, this is going to result in resource blocking or account suspension. So you're violating AWS's environment, their terms of service, basically. And let's get some supporting documentation. Okay, you received the abuse notice. What do? Review the abuse notice. Okay, follow the shared responsibility model. Reply to the abuse report. If you don't respond within 24 hours, AWS might block your resources or suspend your account. There you go. That's it. Okay, so why are the other ones not correct? All right, so trust and safety provides, so it's B. This is incorrect. They don't provide technical support, only abuse investigations. And then C, technical support by trusted safety. So no, this is incorrect. So trust and safety operates independently of support plans. And then D, so instances for the shared responsibility. So this is important, but it's a distractor. It's not an immediate requirement of that abuse notice. This is like a general good practice. All right. And okay, I think we're good. So we're done with domain 1. And I think you had a good time with this. Hope you understand. And we're going to finish off the other 2 domains and then be satisfied. If you enjoyed this, please like, subscribe, share, leave a comment. But I hope you enjoyed and hope you pass your AWS Security Specialty. Have a good day.